Okay, so this is where we left off, and so we can start to cancel some terms. And this will take us to the probability being equal to 2 to the n to the n, 2 to the minus n over, not that these terms are really that useful, but here we have what's left, 1 minus x over n to the x over 2. Here we have a 1 minus x squared over n squared to the 1/2 times the n squared minus x squared over 4 to the n over 2 times 1 plus x over n to the x over 2. And this is equal to all these terms, 2n to the n, 2 to the minus n, one minus x. So I'm just repeating these terms here. What is it that I want to simplify here? Well, I can pull out some terms here. So here, let me just leave this as it is. 1 minus x squared over n squared to the 1/2. Let's pull out the n squared over 4 to the n over 2. And that leaves us with a 1 minus x squared over n squared to the n over 2. Times 1 plus x over n to the x over 2. So this leaves us with a 4 to the n over 2, 2 to the minus n, root 2, root n, 1 minus x over n to the x over 2, 1 minus x squared over n squared to the 1/2, 1 minus x squared over n squared to the n over 2 times 1 plus x over n to the x over 2. And the usual trick here is to take the log of these quantities. So to take the log, and then we'll go back to p again after we've realized that the log can simplify things further. So we'll take the log of p, and that's going to be the log of this number. So this is the natural log, so this number goes in here. Plus, right, the log of this is the same thing as x over 2 log of 1 minus x over n. It's a log of a quantity divided by some other quantity. So we have a minus sign here. So we have a minus for this term. Sorry, where are we? For this term, we have minus 1/2 log of this thing, which is 1 minus x squared over n squared, plus this one's also minus n over 2 log of 1 minus x squared over n squared, and the last one is minus x over 2 log of 1 plus x over n. Of course, the natural log of 1 is equal to 0, and so these terms are, and x is small, so these terms are small. So these terms have log of 1 plus or minus something small. And so we end up with, so it's equal to the log of this number minus plus x over 2 x over 2 times minus x over n minus 1/2 times the small thing that's there is minus x squared over n squared, and then minus n over 2 times minus x squared over n squared, and then minus x over 2 times the thing that's in the parentheses, x over n. And so we get log of this quantity minus x squared over 2n plus x squared over 2 squared plus x squared over 2n squared over 2n. And right, we can see these things cancel, and we end up with log of that number minus x squared over 2n, and that's the log. Right, so log of the probability is the log of this number minus x squared over 2n, and so we'll take the exponent of this to get p back, and so p is some quantity times e to the minus x squared over 2n, and so we see that it's a Gaussian, right? The difference between heads and tails by an amount x starts to decrease, and when x is 0, when there is no difference, that's the peak of the curve. So equal numbers of heads and tails when you have very large numbers. And so we've shown that the binomial reduces to the Gaussian.